Hello students, hope you are doing well. In this video, we are going to discuss understanding SDN and OpenFlow, SDN building blocks of Unit 6 Software Defined Network for the subject Enterprise Network Design of B7 Semester IT, University of Mumbai. In this unit, we will cover Software Defined Network, OpenFlow and Software Defined Network building blocks. Let's now come to the question, what is Software Defined Network? The physical separation of network control plane from forwarding plane and where a control plane controls several devices. So this is associated with devices and these are necessarily associated with cloud and IoT. Okay. So software defined network, it is an emerging architecture that is dynamic, manageable, cost effective and adaptable, making it ideal for high bandwidth dynamic nature of today's application. This architecture decouples the network control and forwarding function, enabling the network control to become directly programmable and underlying infrastructure to be abstracted for application and network services. While the network flow protocol is a foundational element of building a software defined network solution. From our discussion, software-defined network is a network architecture approach that enables network to be intelligently and centrally controlled or programmed using software application. This helps operator manage the entire network consistently and holistically, regardless of underlying network topology. Enterprises, carriers, and service providers are being surrounded by a number of competing forces and monumental growth in multimedia content. The explosion of cloud computing and the impact of increasing mobile uses and continuing business pressure to reduce costs while revenues remain flat are converging to wreak havoc on traditional business model. To keep pace, many of these players are turning to SDN technology to revolutionize network design and operations. SDN enables the programming of network behavior in a centrally controlled manner through software applications using open APIs by opening up traditionally closed network platform and implementing a common SDN control layer. Operators can manage the entire network and its devices consistently regardless of complexity of underlying network technology. So SDN enables consistent management of network which may be made up of complex technology parts. So there are different critical areas, four critical areas mainly. So let us discuss each one by one. Here it shows five, but the first one and fourth one are almost similar. So first thing is network programmability or directly programmable. So first one is network programmability. Okay, so it is directly programmable. Network control is directly programmable because it is decoupled from a forwarding function. So this is also coming under the same window. SDN lets network managers configure, manage, secure, and optimize network resources very quickly via dynamic automated SDN programs, which they can write themselves because the programs do not depend on proprietary software. So SDN enables network behavior to be controlled by the software that resides beyond the networking devices that provide physical connectivity. As a result, network operators can tailor the behavior of their network to support new services and even individual customers. By decoupling the hardware from the software, operators can introduce innovative, differentiated, new service rapidly, free from constraints of closed and proprietary platform. Okay. The next thing is logically centralized intelligent control. Okay, so this is the second thing, logically centralized intelligence and control. So inside that, a network intelligence is logically centralized in software-based SDN controllers that maintains a global view of the network which appears to applications and policy engines as a single logical switch. Fine. So SDN is built on logically centralized network topologies, which enables intelligent control and management of network resources. Traditional network control methods are distributed. Fine. Nowadays, it is not distributed, it is based on cloud. Device functions autonomously with limited awareness of state of the network with a kind of centralized control. And SDN based network provides bandwidth management, restoration, securing, and policy can be highly intelligent and optimized, and an organization gains a holistic view of the network. Then come to abstraction of the network. So this is agile. Okay, so this is third. Abstracting control from forwarding lets administrator dynamically adjust network-wide traffic flow to meet changing needs. So the services and application running on the SDN technology are abstracted from underlying technologies and hardware that provides physical connectivity from network control. Applications will interact with the network through APIs. Okay, so these are the APIs. Business applications are interacting through this API using network services, or all the services has been used by these open APIs instead of management interfaces tightly coupled to the hardware. So hardware is decoupled from software providers. Now come to fourth thing is openness. So open is standard based and vendor neutral. When implemented through open standard, SDN simplifies network design and operation because instructions are provided by SDN controllers instead of multiple vendor specific device and protocol. And this openness SDN architecture user in a new era of openness, enabling multi-vendor interoperability as well as fostering a vendor neutral ecosystem. Openness comes from the SDN approach itself. The open API support a wide range of application, including cloud orchestration, OSS, BSS, okay, OSS, BSS, SaaS, software as a service, and business critical network application. In addition, intelligent software can control hardware from multiple vendors. Okay, with open programming interfaces like OpenFlow. OpenFlow is there. Fine. So finally, from within the SDN intelligent network services, an application can run within a common software environment. A key advantage of SDN technology is the ability for the network operator to write programs that utilize SDN APIs and give application control over network behavior. SDN allows user to develop network aware applications, intelligent monitor network condition, and automatically adapt the network configuration as needed. So let us now talk about OpenFlow. There is OpenFlow switch. Okay, OpenFlow hardware flow table is given. OpenFlow protocol and SSL layer control API network services are shown. Here different controllers. OpenFlow protocol is used. OpenFlow switch is used. So these two diagrams shows two architectures. So after SDN technology, it is generating huge interest in networking industries due to its ability to add higher agility and scalability for the network. At the core of SDN technology is the OpenFlow protocol. Okay, so this is a core of SDN technology, and SDN with OpenFlow switches promises flexibility and fast configuration of communication network. So what exactly is OpenFlow and OpenFlow switch? How does OpenFlow switch work to improve network agility and scalability? So we will try to explain it in detail and clear out the confusion. So let us discuss what is OpenFlow and OpenFlow switch. Okay, here you can see that OpenFlow protocol is given, and this shows the OpenFlow switch. So OpenFlow is a programmable network protocol for SDN environment. So this is programmable network protocol for SDN environment, fine, which is used for communication between OpenFlow switches and controllers. OpenFlow separates the programming of network device from underlying hardware and offers a standardized way of delivering a centralized programmable network that can quickly adapt to changing network requirements. An OpenFlow switch is an OpenFlow enabled data switch that communicates over OpenFlow channel to the external controller. It performs packet lookup and forwarding according to one or more flow tables and a group of tables. The OpenFlow switch communicates with the controller and controller manages the switch via OpenFlow switch protocol. They are either based on OpenFlow protocol or compatible with it. So now let us see how does OpenFlow switch work. How does this OpenFlow switch work? Okay, an OpenFlow switch can only function with the collaborate work of three essential elements. That is flow table, then these flow tables are installed on switch. Flow table installed on switch. Second thing is a controller. Second thing is a controller. And third thing is a proprietary OpenFlow protocol. Proprietary OpenFlow protocol for what? For the controller to talk securely with the switches. Okay, controllers talk to the switches via OpenFlow protocol and impose policies on flows. The controller could set a path through the network optimized for specific characteristics such as speed, fewest number of hops, and it reduces the latency. So now let us talk about traditional switches and OpenFlow switches. In a conventional switch, packet forwarding, the data plane, and the high-level routing, the control plane, occur on the same device. While an OpenFlow switch, the data plane is decoupled from the control plane with the data plane implemented in a switch itself, but the control plane in a software and separate SDN controller makes high-level routing decision. The switch and controller communicate by means of OpenFlow protocol. OpenFlow switch hence the OpenFlow switches are having different advantages. Number one, with OpenFlow enabled switch, the SDN controller could route non-critical bulk traffic on longer routes that are not fully utilized. Second advantage is the SDN controller can easily implement load balancing at high data rates by just directing different flows to different hosts, only uh, doing the setup for the initial flows. Third advantage is traffic can be isolated without the need via for virtual lens. The SDN controller of OpenFlow switch can just refuse certain connection. Fourth advantage is set up a network TAP sniffer easily for that is network TAP sniffer. Okay, so easily for any port or even a specific traffic by programming the network to send a duplicate stream to network monitoring devices. And last advantage is it also allows for the development of new services and ideas all in software on the SDN controller, as well as to accelerate new features and services. So now come to a question that why OpenSwitch is a new trend. OpenFlow switch is designed to provide consistency in traffic management and engineering by making control functions independent of the hardware. It's intended to control. This combination of open source software and commodity hardware holds the potential for unprecedented efficiency and operational agility, which fitted well in world where network becomes increasingly diverse and demanding. Enabling OpenFlow on physical switches and move to OpenFlow switch is something that most clients have been working towards. Okay, so there are different products available like fs.com switch product line consists of 10 GB switch, 40 GB switch, 100 GB switch that supports OpenFlow 1.3, which can be used as OpenFlow switches in open networking environment. So we can say that OpenFlow switch address bottlenecks of high performance and scalability in SDN environment, providing an efficient vendor independent approach to manage complex network with dynamic demand. It is likely to become commonplace in large carrier network, cloud infrastructure, and other networks. So this is all about OpenFlow, introduction to OpenFlow and OpenFlow switches. Let's now discuss building blocks of an SDN deployment. Uh, this particular unit is taken from one book of around 300 pages, and it requires foundation of Internet of Things and cloud computing. Although there are certain things, but because this is theoretical unit, I am just going to explain the concept. Some concepts are beyond the scope of doing or explaining the thing of this video lecture. So let me start building blocks of SDN deployment. So the SDN switches, like an OpenFlow switch, the SDN controller and interface are present in the controller for communication with forwarding devices, generally southbound interface or southbound interfaces are available at open southbound interface are available with OpenFlow. Okay, so this terminology is there in cloud computing and Internet of Things. And northbound interface, the network application interface. Okay, so network application is northbound, means top layer and bottom layer. So bottom layer is OpenFlow and upper layer is the network application, which are the fundamental building blocks of an SDN deployment. Switches in an SDN are often represented as basic forwarding hardware accessible via an open interface, as the control logic and algorithms are loaded to a controller. OpenFlow switches come in two varieties. First is pure and second is hybrid. Okay, so what is the difference between these two? Uh, this is hybrid. Pure means open flow only, okay, and hybrid means open flow enabled. So pure open flow switches have no legacy features or onboard control and completely rely on the controller for forwarding decision, while hybrid switches support open flow in addition to traditional operation and protocol. Most commercial switches available today are hybrid. An OpenFlow switch consists of a flow table which performs packet lookup and forwarding. Each flow table in the switch holds a set of flow entries that consist of the header field. First thing is header field or match field with information found in the packet header, ingress port, and metadata used to match incoming packet. Second is counters used to collect statistics for particularly a particular flow, such as the number of received packet, number of bytes, and the duration of the flow. Action, which are set of instructions or actions to be applied after a match, show how to handle matching packets. For instance, the action might be to forward a packet to a specified port. Then priority with information showing the precedence of the flow entry. Then timeout used by the switch to determine the maximum amount of time or idle time in which the flow should be discarded. Then cookies with the transparent data used by the controller to filter flow entries affected by the flow statistics, flow modification, and flow deletion requests. It is not used in packet processing. And last one is flags that are used to alter the way flow get managed. Like check underscore overlap flag is used to inform the switch to verify that there is no conflicting flow existing on switch with the same priority. So these are the building blocks of SDN deployment. So in this lecture, we have completed SDN, OpenFlow, and SDN building block. In next lecture, we will cover OpenFlow message, controller to switch, symmetric and asynchronous messages. These are the topic for the next video. Thank you very much. Bye bye. Have a nice day. Have a nice time.